Gá bíal sa chathair Páipéar a hain ceist Atal. In this question, we're given z1 is equal to 1 minus 2i. We're told that this complex number z1 is a root of the equation 2z cubed minus 7z squared plus 11z minus 15 equals 0. We're told to find the two other roots of the covenant. So using the conjugate root theorem, we know that if z1, 1 minus 2i, is a root, then the conjugate of z1, so that's 1 plus 2i, is also a root. So using these two complex numbers, we're going to build a quadratic that we're going to divide into the cubic equation to find the third root. So first I'm going to write down z squared minus the sum of the two complex numbers z1 and the conjugate of z1, z, plus the product of the two complex numbers will give me the constant. So z squared minus the sum z plus the product. So first let's find the sum. So 1 minus 2i plus 1 plus 2i. 1 plus 1 gives 2. And minus 2i plus 2i will just give us 0. So the sum is just equal to 2. And then the product of the two complex numbers. 1 minus 2i multiplied by 1 plus 2i. 1 by 1 will give us 1. 1 by 2i gives us 2i. We have minus 2i minus 4i squared. So we know whenever we have I squared, we have to change it to minus 1. So therefore we have 1 plus 4, which is 5. So going back up, our quadratic that we're going to divide in is now z squared minus 2z plus 5 equals 0. So we have 2z cubed minus 7z squared plus 16z minus 15 equals 0. And we're going to divide the quadratic, so z squared minus 2z plus 5 into that. Instead of doing long division, I'm going to use the Roinn model method. So because I have a cubic, I'm going to draw a box which is 3 boxes across and 2 down. I put in the first term of the cubic equation, 2z cubed. I put in the last term, minus 15. So this will help me to find the other factor. So first looking at z squared, when I divide it into 2z cubed, I get 2z. And now I multiply 2z by everything on the top of the box. So 2z multiplied by minus 2z gives me minus 4z squared. 2z by 5 gives me 10z. Now I use my factors of minus 15. So one of my factors is plus 5, so therefore the other factor is going to be minus 3. And now I multiply minus 3 by everything on the top to fill in the two blanks. So minus 3 by z squared, I get minus 3z squared. And minus 3 by minus 2z will give me plus 6z. Now I just double check that I'm right. So 2z cubed minus 15, they're fine. Minus 3z squared minus 4z squared gives me my minus 7z squared. And the 6z plus 10z gives me my 16z, so I know I've done it correctly. So the quadratic is made up of the two roots that we started off with. So therefore 2z minus 3 is my other factor. So therefore z equals 3 over 2 is the other root that I'm looking for. So to recap, we're given one root at the start. We're told z1 is equal to 1 minus 2i. We therefore have the other root because from the conjugate root theorem we know z1 is also a root. We find the sum and the product of the two to build a quadratic equation. We divide that quadratic equation into the cubic in order to find the third root. So in this case we found that z is equal to 3 over 2. On to part B. We're told that w is equal to z1 multiplied by the conjugate of z1. for us to plot these 3 points on the organ diagram. First thing we need to do is find W, but we've already done this in part 1 because we multiplied Z1 by the conjugate of Z1 in order to find the product, which is the constant of the quadratic. So if we just look back up, it's already done. Our W is equal to 5. Had we not done this in part 1, we would have to multiply Z by the conjugate of Z to find it. So plotting W, we have 5 on the X and 0 on the imaginary axis. To plot our Z1, we have 1, just reminding ourselves, our Z1 is 1 minus 2i. Our conjugate, therefore, is 1 plus 2i. We plot our 2 points and we label them. So in the next part of this question, we're asked to find the angle, measure of the angle from the conjugate of Z1 to W to Z1. So I'm just going to draw it on the diagram. So we'll mark that angle with theta. There's 2 different ways of doing this. We could use cosine rule in order to find theta. What I'm going to do is I'm going to look at the right angle triangle that's made with the conjugate of Z1 and W and the x-axis. I'm going to call that angle A. So looking at the graph, we have a distance 2 between the conjugate of Z1 and the x-axis. And we have a distance of 4 between 1 and 5. So that gives us the bottom of the triangle. And now we can use tan of the angle in order to find it. So we use the tan of A is 2 over 4, or 1 over 2. So therefore A is equal to the tan inverse of 1 over 2. So using our calculator, we find that A is equal to 26.5651 degrees. So therefore the angle that we're looking for is twice that amount, because we also have the distance 2 and we have this shared distance of 4 with the other kind of side of the triangle. So therefore that angle is twice A, which gives us 53 degrees when they ask us to round it to the nearest degree.